lecture discusses binary to decimal conversion. In binary number system, it has only two numbers, 0 and 1. And in the case of decimal number system, it has got 10 numbers, 0, 1 up to 9. For example, in the case of binary number system, 0, 0 is a binary number. We usually denote it by writing 0, 0 with a subscript 2 that denotes the binary number 0, 0 to the base 2. Then 0, 1 to the base 2, 0, 0, 0 to the base 2, etc. In the case of decimal number system, we represent numbers as 99, 100, 101, etc. Next, we will see how to convert a number to its decimal equivalent. In this example, the number considered is 345. It is made up of ones place, tens place and hundreds place. Since the base is 10, this ones place is 10 raised to 0. We need to consider the base as 10. Tens place is 10 raised to 1 and 100 place is 10 raised to 2. So the number is 3 into 100 plus 4 into 10 plus 5 into 1. So that is 300 plus 40 plus 5. Now consider the decimal equivalent of the number, binary number 101. The places are 1s, 2s and 4s. That is, since the base is 2, that is 2 raised to 0, 2 raised to 1 and 2 raised to 2. So the number will become 1 into 4 plus 0 into 2 plus 1 into 1. Four plus 0 plus 1, that is 5. Next we will see addition of binary numbers. Zero plus 0 is 0. 0 plus 1 equal to 1. And 1 plus 1 equal to 0 with a carry 1. 1 plus 1 gives you 1, 0. Consider this example. 1 plus 1 plus 0, 1. So if you add 1 plus 1, you will be getting 0 with a carry 1. That is added up. Again 1 plus 1 equal to 0 and a carry. Carry is put in the leftmost side. So 1 plus 0 1 equal to 1 0 0 in binary. Next we will see representation of binary numbers with 3 bits. So with the 3 bit, the first number is 0 0 0. Next number is 0 0 0 1, which we got by adding a 1. And after adding another 1, we will be getting 0 1 0. After this we will be getting 0 1 1. And adding 0 1 1 plus 1. 0 1 1 plus 1 will give you 1 plus 1 is 0, a carry 1. 1 plus 1 is 0, a carry 1. So you will be getting 1 0 0. So next number is 1 0 0. Next number by adding 1 is 1 0 1. Next you will be getting 1 1 0. And adding 1 you will be getting 1 1 1. So these are the numbers we can obtain by with the 3 digits, 3 binary bits. So the decimal equivalent is 0, 1, 2, 3, 4, 5, 6 and 7. So with the 3 digits, you can represent the numbers 0 to 7. So if you convert 1 1 1 to decimal, you can see that this is index 2 raised to 0, 2 raised to 1 and 2 raised to 2. 1 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. We need to start from the leftmost bit. So 4 plus 2 plus 1, that is 7. 1 1 1, binary equivalent of 1 1 is 7. Next we will see few examples of converting binary number to decimal. First we need to write the index places starting from 0, 0, 1, 2 and 3. since we have 4 bits. For conversion, you need to start from the left bit or the most significant bit, that is 1 into 2 raised to 3. The index is 3. Then next number is 1 into 2 raised to 2 plus 0 into 2 raised to 1, index is 1, plus 1 into 2 raised to 0, which is equal to 1 into 2 cube. 2 cube is 8 plus 1 into 2 square, that is 4, plus 0 into 2 raised to 1 equal to 0, plus 1 into 2 raised to 0 equal to 1. You can see that all are powers of 2 only, since we have only 0 or 1. The answer is 13. That is 1101 equal to 13. Next example is 110. Here we have only 3 bits. Again writing the indexes starting from the right, 0, 1 and 2. Then for conversion we need to write from the left, 1 into 2 raised to 2 plus, index is 2, 1 into 2 raised to 1 plus 0 into 2 raised to 0, which is equal to 4 plus 2 plus 0, which is equal to 6. So the next example is 1110. We have 4 bits. Again we are writing the indices 0, 1, 2 and 3. For conversion we need to start from the left, 1 into 2 raised to index, 1 into 2 raised to 3 plus 1 into 2 raised to 2 plus 1 into 2 raised to 1 plus 0 into 2 raised to 0, which is equal to 8 plus 4 plus 2 plus 0, which is equal to 14. Next we will see 1001. Again 4 bits. We need to write the indices starting from the right, 0, 1, 2 and 3. For conversion you need to start from the left, 1 into 2 raised to 3 plus the next 2 numbers are 0, 0 into 2 raised to 2 plus 0 into 2 raised to 1 plus 1 into 2 raised to 0, that is 8 plus 1, which is equal to 9. Next we will see the conversion of binary number 1100 to the decimal. Again we will be following the same procedure, writing down the indices starting from the rightmost bit, 0, 1, 2 and 3. There are in all 4 bits. For conversion we start from the leftmost bit. You can see that since all these binary digits are made up of either ones or zeros, you can directly write the powers of 2 based on the index, that is 8 plus 4 equal to 12.